Hello everyone, welcome to Gangs of PCM. This is Priyanshu and together we are going to solve all your physics related worries. The question we are going to discuss today is from JEE Mains exam held in January of 2020. This question is from chapter rotation, and to solve this question we need to know the concept of moment of inertia. Now let us solve the question. The question is given to us that we have a disk. The radius of the disk is A and the mass is not uniformly distributed throughout the area of the disk. The mass distribution or the density of the areal density of the disk is given by A plus BR. What is this areal density? This is mass per unit area. Mass per unit area. That means as you go away from the disk, as you go away from the center of the disk, the density or mass per unit area of the disk changes. Okay, so how we will solve this question? To solve this question, what we'll do is first we'll take the disk. Let's just draw the disk, and from the center of the disk at radius r, we'll consider a small ring element. Let's consider a small ring element. The thickness of this ring element, let us say it is dr, and the inner radius is r. So what would be the area of this ring? Area of this ring would be area of the outer ring. The radius of the outer ring r plus dr. So area would be pi into r plus dr whole square minus area of the inner part. Inner part would be pi r square. So this would give you the area of the shaded part, a ring element. So from here we get dA is as pi will take common, so we'll have r square plus dr square plus 2 pi, 2r dr minus r square. So r square and r square would get cancelled and dr square would be 0. Why? Because dr is infinitesimally small, and for that small quantity if you square it, it would become more small, so we can neglect it. So from here we get the area element, or the area of the element, as 2 pi r dr. Once we know the area, we can calculate the mass of the element. dm would be how much? dm would be mass per unit area, into given area. This would be our mass. So what is the mass per unit area? That is your density sigma, and given area is dA. Now one thing we have to make sure is that since this element is very small, since this ring element is very small, then for this small element we can consider the sigma to be constant. Okay, so from here we get mass as dm as, let's put the value of sigma, which is a plus b into r. dA is how much? 2 pi r dr. So this gives you dm, which is 2 pi would be common, you'll have ar plus br square dr. So this is your mass. Now this ring element, the moment of inertia of this ring element about the center can be given as mass of the ring into square of its radius, dm into r square. If you solve it, put the value of dm from here, you'll have 2 pi ar cube plus br square into dr. So this gives you dr. Now we need to find out moment of inertia of the entire disk. So this would be given by moment of inertia of these small ring elements. You can see from here, this disk, we can consider a disk is made up of small ring elements of increasing radius. So what we can say, so for moment of inertia of this entire disk can be given as moment of inertia or summation of moment of inertia of the ring elements. So from here we'll get integration of 2 pi ar cube plus br to the power 4 dr. The variable is r, and r is varying from 0 to a. So if you integrate this, from here we'll get what? 2 pi integration of r cube would give you r to the power 4 by 4, putting the limits from 0 to a, plus integration of b would r to the power 4 would give you r to the power 5 by 5, limits from 0 to a. Putting the values of limits, will get what? 2 pi a to the power 4 into a divided by 4 plus a to the power 5 into p divided by 5. We can take a to the power 4 as common, so you'll have 2 pi a to the power 4, a by 4 plus a times b by 5. So this is the answer. Let's look at our options. So from our option, we can see B is the correct option. I hope you were able to learn something from this video. Thank you everyone. See you next time.